Hello students, welcome to the class, and in this video we will be starting with a new unit called as States of Matter. It's Unit 5, States of Matter. In the previous classes we have discussed about the concepts related to the periodic classification of elements and their properties. Hope the concepts are clear to you. If not, you can clarify your doubts. Before starting with this unit, you are familiar with this term, states of matter. Let me tell you what is matter. You however know matter is anything that can occupy a particular space and has mass. Am I right? So what is matter? Anything which can occupy space and has mass. States of matter. We have studied the very important states of matter, that is solid, liquid, gases. And nowadays there are many other different states of matter also, but basically these important three states of matter, using this we can define lot many properties and lot many reactions, say rate of reaction, that means how fast the reaction can take place or how the properties of the substances vary based on their states. States means, I mean to say, solid, liquid and gas. These are the very important ones which you have studied, isn't it? Solid, liquid and gaseous state. Yes? Now, why do we have to study about this particular unit, or why this concept is so important that it has been included in your syllabus and you are asked to know about it? See, in your first year and second year, whatever the concepts you study, these are the basics of the higher concepts. You know about it, right? Now, in this particular unit, first we will be concentrating mostly on gaseous state, and then few concepts related to liquids you will be studying. And about solid state, you have a unit in your second year classes. Now first let me tell you, see, for example, take a common example which everyone are familiar with, water. Okay, what is the chemical formula of water? H2O. Let me write ice, water, steam. Ice, again, what is the formula of ice? It is H2O. What is the formula of water? H2O. What is the formula of steam? H2O. What is the difference here? The difference is its physical state. Ice is in its solid state. Water is in its liquid state, steam in gaseous state. That is all the differences. Here solid, liquid and gas. Now what do we have to know? What is the difference here? Okay, you can just look at the formula and say all these three are same. Whether the nature of it is same? No. You know, ice has a particular property, water has a particular property and steam has a particular property. Am I right? So that means states of any matter. Now water is a matter. It can occupy a particular space. It has mass. So now if I say water, it's say I have told you that it's an example for matter. So its states also, it's important to know about it. That's why we do concentrate on these things. Now these are some basic things. I need not to give you example of solids, give example of liquids, give example of gaseous state. You already know about it. So let us move a step further with the concepts. Basically, let me tell you what are the things you are going to study in this unit. First, you will be studying some introduction concepts in this unit, say about different types of forces, which are very important to know about the states. And after that, you will be studying about some gaseous laws, principles, based on which they have given explanation of a gaseous state. And then you will be studying some concept of how the gases behave, how their nature is, and how the nature shows a deviation. That means how the nature shows a difference. That you will be studying, and some concept related to density. And then comes a few other derivation kind of some concepts of gaseous state only, most probably. And after that you'll be studying some concepts related to liquid state, like surface tension, viscosity, vapor pressure, all those things. Okay, it's a very easy unit and very interesting also to study. In states of matter, now if you have to define the state of any matter, say you won't have to tell whether it is in solid state, liquid state or gaseous state. Based on what do they tell you that it is in solid state, liquid state or gaseous state? Two important factors that determine the states of matter are, one is intermolecular forces, and the second one is thermal energy. Please do follow so that hope the things becomes clear to you of what these things are about. Intermolecular forces, the force of attraction or repulsion existing between atoms, ions or molecules are called as intermolecular forces. See, inter means between, molecular between the molecules. It need not be only molecules, it can be ions, it can be atoms also. Forces. So it can be force of attraction or repulsion. Repulsion means the pushing away force, in the sense the opposite force to that of attraction. So either attraction or repulsion between the molecules, atoms or ions is called as intermolecular forces. Okay, now why do we have to know about this, or how it matters to the state of any substance, or say any molecule or any compound? How does it matter? See, if there is force of attraction, we have studied, see, this is a common picturization, most of us have. When we speak about solid, liquid and gases, solids we say the molecules are closely packed. Yeah, am I right? Liquids, the molecules are not so closely packed as that of solid state. This is solid, liquid and gaseous state. And in gaseous state, the molecules are in constant random motion. The molecules are in constant random motion means they are constantly moving. They are not fixed to a particular position. Whereas in solids, what happens? The molecules are fixed to a particular position. Whereas in liquid, though there is some particular arrangement, but not like that of solids. Whereas in gases, you don't say that the particle is fixed at a particular position. It's just moving all over the given space. Now, how does it matter with intermolecular forces? See, for example, these are the atoms or these are the molecules I have drawn now. They are close to each other. That means, how do you say whether the intermolecular forces are high or low? Intermolecular forces are high. Because the intermolecular forces are high, that means intermolecular force of attraction is very high, because of which the molecules are very close to each other. So you see a regular arrangement, a proper arrangement of atoms or ions or molecules you see. Here, how do you say intermolecular force of attraction is high or is more? Whereas in liquid state, the intermolecular forces, whether it is very strong as that of solids, no. Intermolecular forces of attraction are weaker than that of solids. Yes. Whereas in gaseous state, the intermolecular force of attraction is very weak. Because the force of attraction is very weak, one molecule is not attracted by the other molecule too much. It is just moving here and there. If it was attracted, then it would have held closer. It would have been closer. Are you getting the point? So I mean to say that intermolecular forces are one of the factor which tells you about the different states of matter. Clear? Now we will move with one more. I will speak about this intermolecular forces in detail. I'm just giving you an introduction to the concept. So you need to know what are intermolecular forces. I'll give you the definition also, and then I will discuss about different forces there. And now let me tell you about one more factor, thermal energy. I'm just trying to convey you that which are the factors that is helping us to know about the states of any matter. That's all. Thermal energy. What is thermal energy? Therm means it refers to heat. And when we speak about heat in molecules, atoms or ions, what does it come to your mind? How heat is produced? In such systems, say in physical state when we speak, because of motion of molecules, can I say, movement of molecules? When the molecules move faster and faster, more heat will be produced. When molecules move with little bit of speed, slightly less, then again if it is very weak, then too less. Yeah. Thermal energy means the energy possessed. That means the energy the molecule has due to its motion. That means due to the movement of molecules, what energy it possesses, it has, that energy is called as thermal energy. In other ways, how can we tell it? I can tell it in terms of kinetic energy also. Energy with respect to motion. So kinetic energy. Kinetic means which is related to motion of particles or movement of particles. Yes. So I can also tell that the energy possessed by the molecule due to kinetic, or say kinetic energy possessed by the molecule in simpler words, is called as thermal energy. Clear? Now let us go deep into the concept one by one. First let us study about intermolecular forces. In intermolecular forces, intermolecular forces. So how do you define it? The forces of attraction or repulsion between any two atoms or ions or molecules are called as intermolecular forces. Hope this point is clear to you. The force can be of attraction or repulsion. So that forces of attraction or repulsion between any two atoms. Same atoms means, say for example, this is one hydrogen atom, this is one more hydrogen atom. The force of attraction between this, because there is force of attraction, it has been held together or closer. Ions means, say for example, Na plus Cl minus. If they have a force of attraction here, what do they form? They form NaCl. Or molecules, it can be one water molecule and another water molecule. If they have some force of attraction, then we can say that there exists intermolecular force of attraction. In intermolecular forces, inter means between molecular forces. I need not again tell about it. Here comes a concept called as van der Waals forces. A Dutch chemist by name van der Waals, he explained this particular force, and it is called as van der Waals forces. So attractive intermolecular forces, van der Waals forces. How do you define it? Attractive, I have told you, isn't it? There are two types, so either attraction or repulsion. So attractive, if it is attractive intermolecular forces, then you call it as van der Waals forces. What is van der Waals forces? Attractive intermolecular forces are called as van der Waals forces. In van der Waals forces, we have different types, very important. One is, the types of van der Waals forces are, hope you are noting down the points, and please don't be lazy to follow up the points. Keep on revising the concepts whichever you have noted down. The home assignments has to be submitted on time, and the concepts that you are studying has to be registered in your mind, isn't it? So keep repeating, have your self-test. We also will be conducting test, so do follow it. Okay. Different types of van der Waals forces are, one is dipole forces. Other one is dipole induced dipole forces. Next one is induced dipole. Do not get confused, I'll tell you what it is. It's easy. Induced dipole forces. So these are the three types of van der Waals forces. Now let us study one by one in detail. First, let me tell you about dipole forces. What do you mean by dipole? D-I, not D-I-E. So D-I-P-O-L-E, pole. Pole means, for example, we say North Pole, South Pole. Here dipole means positive and negative end. So dipole means which has two ends. One end is of positive we consider, the other one of negative we consider. Clear? So dipole forces means the force of attraction that exists between the two polar molecules. Do you know what are polar molecules? Polar molecules means which has a positive end and a negative end. This way. See, in simpler words, I'll just explain you this in this way. If this is a molecule, it will have one positive end and a negative end. That means the positive charge is concentrated at one end, negative charge is concentrated at another end. Such molecules are called as polar molecules. This is one polar molecule now. If there is one more polar molecule, with positive end and negative end, then if they both have force of attraction, we call it as dipole interaction. See here, it's positive end. This is negative end. Negative attracts positive. Am I right? Now see, this is one more molecule. Its positive end will be attracted by another molecule's negative end. So if there is a force of attraction between these, we call this force of attraction as dipole forces. This is one simple way how you can define dipole forces. The force of attraction that exists between two polar molecules or two molecules having dipoles, you can write. Okay, I'll just give you the definition of it so that hope you don't find it difficult in ways. Simply do not note down the points as I simply write on the board. Do try to frame the sentences and statements and write it, so that you will have a good standard notes. You can deliver the same in your examination also. Okay. What is it I was speaking about? Dipole forces. What is it? The force of attraction that exists between two molecules having dipoles. So I have written force here, so you will write is called, write this, dipole forces. Please do write it completely. Clear? The force of attraction that exists between two molecules having dipoles is called as dipole forces. Just write a representation of it, plus minus. This is one dipole, this is one more dipole. So we call these molecules as polar molecules. Polar molecules means having one positive end and one negative end. Now water is called as polar solvent. Why it is called polar? See, in water H2O, here we have a negative end, we have positive end. See, a dipole you can see. That is why we say that it is a polar molecule. Now the force of attraction denoted this way. This indicates force of attraction between them. And here you can just indicate with an arrow mark that this is dipole forces. In easy way, if you are finding the definition difficult, you can also define it as the force of attraction that exists between two polar molecules is also fine. Hope you are following it. So if there are molecules which possesses dipoles, and then if there is force of attraction between them, you call the force as dipole forces. Yes. One example let me give you. Say, since I was telling you plus and minus, one example is HCl. So here in HCl, H is a positive end, Cl is a negative end. This way it will be. Here H, this is Cl, here plus, here minus. Otherwise let me write this way. HCl. There is a positive end, there is a negative end. Same way, how do they attract? One more HCl molecule, say, here H, here Cl, HCl. The force of attraction between the polar molecules is called as dipole forces. Clear now? Okay. Now let us see the next type of forces, which is called as induced dipole forces. Dipole induced dipole forces. Here you know what happens. Here dipole means, now you are familiar that dipole means which has two ends, positive and a negative end. Induced dipole, inducing means bringing the dipole there. Earlier there won't be any dipole, but bringing a dipole and then they will be having a force of attraction. No? That is called as induced dipole forces. So now we will study about it. So here what happens, I'll give you the definition, do not worry. Here what happens, you know, one will be a polar molecule already. One will have a dipole, this one. Polar molecule. Polar molecule. The other molecule will be a non-polar one, say plus. Only it has only positive charges now. Non-polar, which does not have two ends. Non-polar molecule. Now what happens? Do you expect that there will be force of attraction between these? But still, in few cases what happens is, earlier the molecule may not have dipole here. When it comes closer to this polar molecule, now what it does is, this polar molecule will try to induce a dipole in the other molecule nearby. That means this will be like, okay, see, you have only one charge. Let me, it's like this, not exactly. It'll be like, okay, let me give you some charges so that even you will become dipole, and then we will have force of attraction. That is how it happens. So when a non-polar molecule approaches polar molecule, which it comes closer, then gradually what happens is, this non-polar molecule, no, it will become polar molecule like this. Now what happens? Earlier it was a non-polar molecule, now it has become a dipole molecule. So these both will have force of attraction. The force of attraction that exists between a polar molecule and a non-polar molecule is called as induced dipole forces. Otherwise, in another ways, how we can say, the force of attraction that exists between a molecule having dipole and the other molecule in which dipole is induced is called as induced dipole forces. Hope I'm not confusing you. The force of attraction between a polar and non-polar molecule is called in dipole induced dipole forces. So you can write it this way. Earlier it will be non-polar, polar, non-polar. But after that what happens? Here you can write induced dipole. That means it has got a dipole which was not there earlier. Then show force of attraction between them. Clear? So if you show that this way, then it is then it would be better if this is shown like this. Otherwise you can write here permanent dipole, here induced dipole. Okay.